Hello everyone, welcome back to Everything Swift. Today we'll be tackling Leetcode question 189 titled Rotate Array. So we are given a nums array here, which is of type integer array, and we are given k, right? So k represents the number of steps that each integer value inside this nums array that is supposed to move, like how many steps that particular value has to move within that array, right? So I'm going to use this example here to explain what we are supposed to do, right? So 1, 2, 3, 4, 5, 6, and 7, right? And our goal is to get to 5, 6, 7, 1, 2, 3, and 4. So essentially, how do we get from here to here, right? So k, as I said, represents the number of steps that each integer value has to take to rotate themselves within the array, right? So let's see. So 5 have to rotate 3 times, right? Because k is 3, so move 3 times. 1, 2, obviously there's nothing outside here because this is the last index inside the array, so it will have to go to the first index of the array, right? So 1, 2, nothing here, goes to the first array, 5, right? Same for 6, 1, nothing here, 2, and 3, 6 is here. Same thing for 7, nothing here, 1, 2, 3, so 5, 6, 7, there we go. Same thing for 1 here, 1, 2, 3, and here's 1, and same thing for 2, 1, 2, 3, get to 2, and then 3 is the same thing as well, 1, 2, 3 comes here, and 4, the last one, 1, 2, and 3. That's how we move from here to here. Every integer moves k number of steps, right? So that's the gist of the question. The question is how, right? How do we get from here to here? So I think this is one of those questions that you have to do to kind of like recognize the pattern, because at least to me, when I was starting out doing this question, I did not recognize this pattern on first glance. So definitely you have to sort of like do it to see it kind of question. So hopefully this question will give you some hint to how to solve these questions, right? So the strategy to tackle this problem is basically broken down into 4 main steps, right? So I'm just going to write it here. The first step is to find the pivot point inside the array, right? I'll explain that later. And then basically we need to rotate the entire array. And then after that, the third step is to rotate everything before the pivot. And the last step is to rotate everything after the pivot, right? So this is our strategy, right? 4 steps to get from here to here, and the best thing is we don't have extra additional space, and I think the time complexity for this operation should be O of n, because we're just traversing the array with no additional space. So let's see, the pivot point is basically a modular operation, right? So pivot formula is basically the number of steps, which is k, modular the length or the count of the array, right? Which is this. So in this case, this example here, 3, right? Our count here is 7. So 3 modular 7 will give us 3. So the pivot is 3. So why do we do the modular operation is essentially to ensure that our pivot point is a valid index of this array. So because k can be any number, we don't want to use that as the pivot point. But if we use modular, we will be sure that this pivot point acts as an index that exists within this array. We will not have to deal with index out of bound. So that's why I chose to use that modular operation to do this. So that's the first step. The second step is to rotate the entire array, right? I think this step will really give you the glimpse of like how do we get from here to the final step, right? So if we rotate the entire array, we get 7, 6, 5, 4, 3, 2, and 1, right? So as you can see from here to here, right, you can see some sort of pattern here, right? 765 is basically the descending order of 567, and 4321 is the descending order of 1234, right? So basically, as we can see here, the pivot is 3, right? So k, which is k number of steps, which is 3, modular nums of count, which is 7. So 3 modulo 7 gives us 3. That is the pivot. So if you look at the pivot point here, right, that is sort of like the separation, right? 765 is like the one portion, which is this one, and then the other portion is this side, which is after 3, right? So as explained here, the next step is basically to rotate everything before the pivot, right? So everything before the pivot, which is here, which is the 765. So let's rotate it, right? So we will get 567, 4, 3, 2, 1, right? So let's take a look at this. So 567 is exactly what we need, right? 567. So basically all the numerical numbers before the pivot point has been rotated, and looks like that matches our final output, right? Then the last step is to rotate everything after the pivot for 3, 2, 1. Let's go ahead and do that. So 567, 1, 2, 3, and 4, right? So as we can see here, it matches, right? The output and the solution here seems to match up, right? So basically, that's our strategy. 4 key components. Find the pivot point just to ensure we are not going to deal with any index out of bounds. Rotate the entire array. Rotate everything before the pivot, and the last step is rotate everything after the pivot, right? So for main step, let's go straight into the code and see how we're gonna achieve this. As always, I'm going to check if the array is empty. If it's empty, basically there's nothing to rotate, so we can just return here. And then the pivot here, I'm just going to call it k, k modular nums of count, right? So k here is the pivot point. Because we're going to rotate 3 times, I'm going to create a helper function here because, yeah, I just want to repeat myself 3 times. So I'm just going to call it, I guess, swap here. I'm going to pass in the array, the starting point, and the ending point, right? So I have to manipulate the start and end index to ensure we can exit out of this function here. So I'm going to convert them as a variable, var end, var start, and then while start is less than n, basically what we're going to do is swap at start and end, right? And obviously to break out from this operation, we have to update our start and end index bounds like this, right? So basically this function here is basically doing the rotating for us, the reversal. So we are using this swap add function that is built into the Swift array collection, right? So once that function is set up, all we have to do here is call it nums. So the first step is to rotate the entire array. So first index is 0, last index is nums minus 1. Minus 1 because we are dealing with index base, so which is 0 base index, so minus 1. So once the entire array has been rotated, rotate everything before the pivot. So swap add nums, basically before, so 0k minus 1, right? And then once this step is done, we proceed to the last one, rotate everything after. Swap nums, everything after, so k, all the way to nums.count minus 1. And that should be it, right? 4 key steps: finding the pivot, rotate entire array, rotate before the pivot, rotate after the pivot, right? So let's go ahead and try and run this. Hopefully we got it right. There we go. Let's try and submit this, and let's see. And there we have it. That is the solution. We seem to got it right. So yeah, hopefully this video is kind of helpful to you guys, because on first glance, like I said, when I tried to attempt, it wasn't very clear. But I think like once you see, especially this after this second step, it's pretty clear like what we have to try and do. So hopefully that helps out if you are attempting this question, right? So as always, thank you for watching. If you know anyone who is interested in contents like this, please feel free to share my channel. I'm trying to put out more video contents like this in the future, and I'm trying to grow this channel as well. So I appreciate your help. So yeah, I think that's it. Thank you, take care, and bye bye.